Okay, here we go. So now I will be introducing how I implemented speech dictation in our ELN application. So, developing a hands-free ELN capability. So the question we proposed to start us on this path was, can a machine learning-based algorithm translate scientific language in terms of voice to text accurately? We're moving towards a more hands-free ELN for various reasons. The first being that typing in the lab is frequently not practical. It poses the risk of cross-contamination, and certain settings really require a user to keep their hands free. Because of this, some users can't bring their laptops into the lab. So speech dictation is the start to the solution. This will greatly improve process optimization as the capabilities of the model we use can minimize mistakes. This more hands-free format will allow a user to multitask in the lab and will almost act as a lab assistant, helping the user through their voice. So this is a general outline of the process of speech recognition in ELN. So I'm here to present the initial findings of speech to text in ELN. The first step was implementing a model that could actually answer our initial question and handle those higher level scientific terms. The next step was integrating our model into our ELN application. And then the next steps will actually be ELN application navigation through speech recognition, integration into other apps, mobile app development, testing, product launch, and so forth. So this is the actual model we're using. So the automatic speech recognition system we implemented is actually OpenAI's Whisper. If you're kind of up to date, I'm sure you've been hearing a lot about OpenAI with ChatGPT, DALL-E, and so forth. This model actually has a word error rate that's comparable to Google, AWS, Microsoft. Those are all actually around like 4.9 to 5, while Whisper actually has a 4.2% word error rate. But the main reason we implemented was for its ability to handle higher level scientific terms and IUPAC names, making it perfect for lab settings, procedure boxes, and more. It also has the ability to use proper punctuation when you dictate, and it can ignore most of the background noises that can frequently be happening around you in a lab. So test deployment in our ELN application. So the process of selecting a model was actually one of the biggest challenges. We went through various other models, including Mozilla's Deep Speech and Facebook's Wave to Vec, but even with the additional fine tuning and training with all sorts of higher level scientific languages, the models were still not reaching a usable word error rate regarding all of these scientific languages. So then once we arrived at OpenAI's Whisper, the next challenge was capturing optimal audio in the browser. Speech recognition models typically require audio files in certain formats and with various parameters passed to them as well. So we had to actually capture the format and format it properly for Whisper to be able to process. And now here's an actual visual of the user interface of speech dictation. I have a screenshot here of an experiment notebook open here in ELN. Just for this demo, I'm using a button click to capture and record audio for visualization purposes, but in the future, this can change. And now I will show a quick video of this exact model in play. I'm hoping the sound will be able to share as well, but I'll give it a shot. As mentioned earlier, 3-bromo-2-aminopyrazine was chosen as a versatile intermediate. The established methods for the synthesis of bromopyrazine involve the treatment of aminopyrazine with molecular bromine and acetic acid, bromine and pyridine, etc. However, bromination with NBS proved to be a more efficient protocol among all the methods available. Okay, so here you can see the actual dictation that was just transcribed from the audio I captured. Hopefully you guys were able to hear that as well, but you kind of see a bit of an IUPAC name in play here, as well as lots of other higher level scientific terms. Okay. Shoot, sorry. And now at future development. So our next steps in play will be actually the ability to navigate the ELN application through speech recognition. So this would be actually using voice commands to get around the ELN application. So moving from tab to tab, moving to different parts, selecting things and so forth. We also plan to integrate into other applications such as inventory. So this could be very helpful for sample management, actually using data inputs more. And then mobile app development as well, so that you can be working in the lab hands-free from a mobile device. You don't always have to be using your laptop. And that is all for me today. Thank you. And I will check to see if there are any questions.
Thank you very much, Sena, for the talk. I'm not seeing any questions at the moment. As Joanna mentioned earlier, if you have any questions, please don't hesitate to type them in the Q&A feature of our webinar. All right, it seems like there might not be any questions at this moment. So I wanted to thank the participants for joining our webinar today. I hope that you were able to, oh, thank you, Joanna. Thank you. I hope you're able to get an idea of what we're working on here at Scilligence. I think it's very exciting. We're future-proofing our product, and we have a lot of young developers that are really taking advantage of the emergent technologies that are coming up rather quickly in our industry. So, you know, as you saw, Jason and Sena's use of AI to enhance potential productivity for both biology and also for speech to text features in the future, I think are quite exciting and unique ventures into something new that we could utilize in our product. Of course, Kevin's talk on lipid nanoparticles really points out a key missing need in the software industry to capture that type of modality with the lipid nanoparticles. Scotty's excellent talk about mold-to-helm capabilities, and in particular the case studies, how we helped our clients address the migration of data that is unstructured or worse, is not Helm optimized, really goes to show how that Helm technology can go a long way to help the industry, to help our clients, and to boost innovation. And of course, we always start working on our existing products. We don't rest on our laurels, as I showed you earlier with the new features that we have on our conjugate builder. We have plans to keep expanding our capabilities and to keep enhancing our existing features. So with that, I thank you again for joining us. Until next time, take care. Thank you.